Don't worry. Okay. Right. Yeah, my favorite.
All right, happy Tuesday. How's everyone doing? You have a nice weekend? Yeah, me too. This is what I was doing. Going on long walks with a cute little child. So we have a good one today. We're starting with data visualization. We started, working with data sets last class. So we downloaded a data set, we opened it in Excel. We did a few things, some very basic operations. And then we we got sort of familiar with Python. A lot of you, I think, I was hearing after class, still have a lot of work to do to feel comfortable in Python. And that is A-okay. We are like week 2 of the semester. It's very appropriate to feel like you aren't fully comfortable with Python. So if you're in that category, feel comfortable there. That's just where we are at the moment. We're going to do a little bit of work in both Excel and Python today. I'm going to show you how to do the same things in both pieces of software. The way we as people who work with data think about Python, we think of it as essentially doing the same kinds of operations as what we do in Excel. It's just we do it with code instead of with a spreadsheet. So that's where we're going today. Before we get in, are there any questions? You all have a nice weekend? Okay, love to hear it. Hopefully you didn't do a lot of work for me over the weekend. Hopefully you're able to get all your work done during the week. And you can go enjoy the nice weather. It won't last forever, but it's here right now, so enjoy it. Okay, unfortunately, I'm gonna have to close this picture. So we left off talking a bit about the survey results. We didn't have a lot of time to get into all of it, so I just wanted to show you a few things about who's in the room. I find this pretty interesting to do at the beginning of a semester. And I'm going to demonstrate some data visualization best practices. I'm going to show you some of these as we go through. We've already seen some of this, so I'm going to go pretty quickly. So this is just a visualization of like where everyone's coming from. One way of doing this would be to collect information about like the state or country of your hometown. But I chose to do this in a slightly different way to measure where you're coming from based on how many miles away your hometown is. And so the picture looks like this. We did something like this in notebooks last time, but this is just a nicer figure showing how far away your hometown is. So if you're more than like 2,500 miles away, you must be coming from international, unless you're like in Hawaii or Alaska, I guess. So we have a few international students. We have a big clustering of distances much closer to 0. So one thing I would want to do is zoom in and try to figure out generally the distances from this clumping of data. So that's what I did. I zoomed in just to distances that are under 1,000 to get a better picture of this subset of the students in this class. And you can see a lot of people are coming from Pittsburgh directly, so this is like the Pittsburgh metro region. And anyone know like where 300 miles away might land us? Yeah. Where? New York. Yeah, so New York is roughly 300 miles away. What's maybe another major city? Philly, yeah, which I think almost everyone, or a lot of people in this group, are coming from Philly. I think New York might be a little bit further than 3, might be like 400. Okay, yeah, so more eastern. What's your name? Tony. And what's your name? Are you from Philly?
Yeah, I guess right.
Nice. Yeah, how many of you are from Philly? Or like Philly area? Nice. Okay. So I have family in the Philly area. In Philly, Fishtown, and in the suburbs of Philly, like Quakertown, Doylestown area. So nice. So this is like eastern Pennsylvania or New York, kind of that area. Maybe New Jersey too. Nice. And then we looked at when people are born. So this is a different way of measuring age, just like when your birthday is. And I zoomed in on this main clustering of ages. There was someone born in the 90s. That was me. But yeah, most people in the class are born in this range. So you can see the most common birth year is 2005, but 2004 and 2006 are also common. We sort of already looked at that last class. We also looked at majors, but this is just a nice visualization of this. This shows two things. One, most people in the class are majoring in Econ, and two, I can't predict all of the majors on the list. A lot of people are in other. As I said, deep apologies for this. I should have collected which major you actually are, and just had you report that. So this is interesting. Finance is the second most common primary major, and then a lot of computer science. So we've already seen a lot of this. And I just wanted to show you a couple of things about the stats and the relationship to what we're doing in this class. This is the histogram of whether you liked your stats class. You'll remember I was at the very bottom here. It's nice to see that a lot of people liked your stats class, which is great. We're going to be doing a lot of statistics stuff a bit later. One question you might ask of this data, as we talked a little bit about, is whether you liked whether there was a relationship between whether you liked your statistics class and whether you're excited about this class. And I plotted this data set, the scatter plot, in some detail last time, but I think this is a better figure. So on the horizontal axis, I have how much you liked your statistics class. This is what's called a joint plot, which we'll talk about a little bit later. It's kind of fancy, so I don't want to make things too fancy right off the bat. But I have a histogram of whether you liked your stats class on the top here, and then on the vertical axis, I have how excited are you for this class. And it turns out, thankfully, a lot of people are somewhat excited. I collected this before we did Python last class, so maybe this has gone down a little bit. But on the vertical axis, we have your excitement for this class, and then I have a histogram of that excitement on the vertical axis. And going in, like when I collected this data, I would suspect that there's a positive relationship between these two variables. And generally, that's what we see. If you liked your statistics class, which is maybe the closest previous class to what we're doing in this class, you would come in with maybe a little bit more excitement for what we're doing in this class. And the data is noisy, and as you'll see as we go through the semester, often what we do, the data sets we work with, the data can be pretty noisy. So there isn't a very clear trend. But you can see that there's potentially a positive relationship. A lot of the density in the scatter plot happens right around here, although there are outliers on both sides, or data that sort of is distributed around the central trend. But it looks like generally, if you liked your stats class, you're more excited for this class, although the pattern isn't quite that clear. Okay, and then another thing we might ask is your confidence in Excel related to your excitement for this class? And when I collected the survey, I asked you, I told you that we would be using Excel before I collected the survey. So you knew that there was Excel in this class before I asked you about your excitement. What I'm doing here is actually splitting up the data into two groups. One is people who feel confident in Excel, and that's the box plot on top. And then I've listed everyone who's not confident in Excel in this second box plot, so in the one on the bottom. And I've also included this the second kind of visualization on top, which is just plotting the actual data points. So these are, each one of these dots represents a student in the class. And what you can see is, generally, if you're more confident in Excel, you're more excited for this class, which, as we go through the class, I hope to convince you, if you came in without Excel, you should still feel very excited about this class. So as you go on, you'll learn that you can do everything. But just coming in, it looks like people who have some experience are more excited for the class, which is interesting. And then the last thing I wanted to show you is whether confidence in Python is related to your excitement for this class. So just like we did with Excel, we're going to look at the relationship between Python confidence and excitement for this class. And what you can see is the histogram at the top here is just the distribution of your excitement, your confidence in Python. And as I showed you earlier, most people in this class, understandably, are not that confident in Python. For a lot of you, this is your first time working in code. If you have no prior experience working in code, this class is the place to be. You should feel very confident that if you have zero confidence in Python, that you're in the right place. So many people are not that confident in Python, and you can see the distribution in that group of excitement for this class. And I think the trend here is a little less clear, but it looks like there might be a positive relationship between confidence in Python and excitement for the class. But a few people, it looks like there might be a upside down U relationship. But this scatter plot isn't that conclusive. So there's not a strong relationship between excitement for the class and Python experience, which is potentially understandable. You don't have to come in with prior experience to feel comfortable in this class. So maybe there's a lot of excitement in just learning Python, which is, I would feel the same way. Okay, so these are just some general findings. I wanted to present this to you at the beginning. I think this is pretty interesting. This is, at least for me as someone who works with data, this is an interesting way of understanding trends in a population. And this is not something we could have figured out if I had just asked you these questions on day one. We needed something systematic. We needed a systematic way of understanding the population, and that's something we can do with data. And when we have the correct visualization, it makes it much easier for us to understand relationships in our data. So what we're doing today is starting at the ground floor. We're going to start working on creating good visualizations using best practices for doing visual summaries. So I'm going to ask you a set of questions over the next couple of slides, and you're going to tell me some answers. Ignore the takeaways. We're going to start working with categorical variables, and then we're going to get into an exercise and actually do some of this in Excel and Python. But the thing I want you to be focusing on as we go through these slides is which figure is easier to understand. We want to think, one of the key ideas with data summarization is when you create a figure, you want that figure to communicate as simply and as easily to your audience the point you're trying to convey. And the best visualization tool isn't all the same across every type of variable. This is one of the big points. Each variable type has its own best visualization tool. I'm going to show you sort of a summary of which ones are which a little bit later, but I want you to be thinking about which visualization tool is better, which one is easier for you to read as an audience member or as a participant in this class. Okay, so I have a data set, and you can go to the website and we'll work with this data set a little bit later. So if you want to just take a look at it, you can. So you can download the coffee shops data set here if you like, but you can also just follow along as we go. But this is just a visualization I made from that data set. And what I want you to be thinking about is which of the figures that I'm presenting is the best and easiest visualization to understand the question at hand. So for this slide, the question is, which state has the most locations? So I'm going to give you like 10 seconds, just look at this, pick the one that seems like it's easier to understand, and then I'm going to ask you which one you prefer in a second. Okay, so we have two options. We have the bar plot, and we have the pie chart. If you're trying to figure out which state has the most locations, how many of you prefer the bar chart? And how many of you prefer the pie? Okay, interesting. So I want one representative from both categories to make your best case. Someone from the bar chart. Why do you prefer the bar for this question? Yeah.
Because it's a number, like not a percent.
Okay, nice. So a bar kind of represents more of like counts, where a pie chart sort of represents maybe more percentages. Yeah, remind me of your name. Chase. Yeah. So that's a great summary of why people like bar charts better. Yeah.
Well, I was gonna say the pie chart's probably bad because pie chart represents like 100%.
Okay.
And if you're viewing by states, those aren't every state in America, so it's a little deceiving.
Sure. Yeah, remind me of your name.
Matt.
So Matt is pointing out, potentially we have coffee shops that are not in this data set in the country. Like, definitely there are coffee shops in Pennsylvania. I went to one this morning, and they're not in the data set. We have a lot of ideas about potentially pie charts representing the percentage of a whole, and so maybe they're not appropriate for this context. Yeah.
I maybe would have chosen the bar graph if it was ordered better. So
Oh, sure.
kind of like seeing it from increasing to decreasing or decreasing to increasing.
Yeah.
Probably would have made it more visually appealing to me.
Yeah.
But the pie chart, just seeing, I don't know, just seeing it kind of next to each other like that is easier for me to kind of see that California has like the biggest, like the most like coffee shop locations. But,
Yeah. So remind me of your name. Ruby. And it's Matt and Chase. So Ruby's pointing out, potentially one thing we could do to improve the bar chart is actually order the categories based on their counts, which is something we're going to do in the slides in a second. Yeah, so that's great. So Ruby's maybe saying, like, just intuitively, the pie chart may be a better tool. Yeah.
Yeah, I think it's easier to just look to the pie chart and see that California is the biggest chunk. And I would say the biggest difference is being able to see that California has a count of 6 much faster with a pie chart than the bar graph.
Yeah.
Because you have to first identify, okay, which one's the longest, you see that's California. And then you have to look at the x-axis to see, okay, that's 6.
Totally.
So it's all in one in the pie chart. I don't see anything necessarily wrong with bar graph. I think either could work.
Yeah.
But I feel like if you're trying to convey the information as fast as possible, and make it easy for any audience, I would say the pie chart.
Yeah, that's great. Remind me of your name?
Luke.
So Luke is saying, maybe agreeing, let's see, Ruby. So Luke is agreeing with Ruby generally that in this case, the pie chart may be quicker to view and just see sizes relative. But also, Luke is pointing out the pie chart has numbers just built into the areas. So like the number is listed on top of the pie slice, where to figure out the actual number with this bar chart, at least the way it's set up, is you have to find which one is the largest and then sort of run a line down to the horizontal axis to find the number. And just like Ruby, we're actually going to do this in the slides. We're actually going to improve the bar chart to make it better in that way. But the default in general, and you'll see this in a lot of bar charts, is to not do that, to not include the number on the bar. But the good ones do, and I'll show you those, an example of that in a second. But the nice thing with pie charts is they sort of come built in with the numbers labeled on top. I think I agree with the majority of the class that for me, the bar chart is easier to read. If you're trying to find the largest, all you have to do is look which bar is furthest out on the horizontal. Here, it may be just with visual instincts, it may look like Texas and California are pretty similar, where it's really clear from the bar chart that Texas and California are not similar. California has 50% more, where it's not quite clear from the bar chart that that's true, unless you read the number. Okay, so with this example, it's a little maybe murky. You could go either way. If you're just trying to find the largest, I would say both can potentially work in this case. What about this example? Does Florida or Washington have more shops? I'll give you 10 seconds to pick which one you like better. Okay, 10 seconds. I want this to be brief. I want you to, when you see a figure, I want you to think instantly which one you like better. Does it communicate what you're trying to do? If it's not quick, if it takes a while to read, there are probably ways to improve your figure. Okay, so how many of you prefer the bar chart for this question? And how many of you prefer the pie chart? Okay, even stronger consensus, although maybe not full consensus. So someone tell me why this case is, the bar chart is really useful here. Yeah.
I mean, the actual number doesn't matter. You just ask which one has more. It's very easy to see. Florida bar is higher than Washington, so.
Yeah, so all we have to do is identify the two categories, and then we can compare their height on the horizontal axis. And you can see Florida definitely has more than Washington. And what's your name?
Alexis.
Alexis, yeah, thank you. Someone else from the bar category want to represent, yeah. Yeah, it's so hard to read the pie chart for this question. You have to like do some like unit circle, like angle comparisons, right? Pretty tough. You can look at the numbers, so Washington and Florida, but if you're just seeing the sizes, which is the main reason we want to use figures, is for visual sizes, essentially. That's pretty tough to see. At least for me. Anyone want to represent pie charts? Yeah.
When I look at these, I just look at the numbers. So as soon as I see like 3 and 2, I just like know right away rather than looking like, oh, it's like 1 and 3. You know, it's like probably pretty clear on the bar chart. But for me, I just go straight to the numbers.
Yeah, great. What's your name?
Alex.
Alex. And Alexa? Alexis. So yeah, Alex is saying, look, the numbers are really valuable. When we put the numbers on the visual component in the figure, it just makes it much easier to read. And for Alex, that part is what sort of crowds out the rest of what's going on in the figure. Just the number is really nice. Okay, so generally for me, I think I agree with the majority here. We don't have to follow consensus in this room, but for me, the bar chart is just especially good in this case. And I would say best practice, really no one uses pie charts. I'm going to show you one example of when a pie chart could be, I would say, equally good as a bar chart, but you'll basically never see pie charts in scientific work. We just basically never use them. And to such an extent that the main visualization package that we will use in this class actually doesn't even have one built in because we just don't use them. I'll show you one example of when we do use them in a second. Okay, so how about a third question? If you're trying to figure out how many shops are in Florida, which one is easier? 10 seconds. Okay, hands for bar chart, hands for pie chart. Okay, someone tell me why. Yeah.
With the pie chart, you just look at it and you don't have to interpret anything. With the bar chart, you have to look at it and figure out what's between two and four.
Nice. So the bar chart, you have to look at which bar and then run a line to the horizontal axis and then figure out what that number is. Where in the pie chart, all we have to do is find the slice and then see the number. What's your name? Hannah and Sophia. I don't think I asked you for your name, so Hannah and Sophia. Hannah is saying including the number on the visual component actually is very helpful for us when we're trying to figure out the answer to this question particularly. So you'll see the question we ask impacts which visualization and which visualization we would choose, and it also the visualization, the way we construct it is useful for answering different kinds of questions. So these are things we need to be thinking about. Going back to Alexis. Going back to Ruby's earlier comment, what if we add numbers to the bar? Or was that your comment, Luke? I can't remember.
I don't know. I just don't want to take credit for someone else.
I'll give credit to both of you.
Yeah, that works.
So one thing we might do is just essentially copy the idea in a pie chart, at least the original pie chart, and we're just going to put the numbers on the bars themselves. I find this much more useful than having a horizontal axis that we have to read. I'm just doing the visual work for you, which is that's the main idea of a visualization. I want to do the work for you. I want to tell my audience in as simple a way as possible what is contained in the data. And as an audience member, this is nice for you, right? Like, you love this. It's much easier to understand what's in the data set in this way. A visual is intended to save the audience work. Okay. So how many shops are in Florida? How many of you prefer the bar chart in this case? And how many of you still prefer the pie chart? Okay, maybe mixed. Maybe they're equal here. I would say potentially they're equal. I'm going to show you another trick that we can do. Now that I have included the numbers on the bars, that horizontal axis actually means nothing anymore. It doesn't add anything extra to the figure. I don't have to use it to interpret the size of the bars. So what I did is I actually got rid of the horizontal axis for the bar chart. So now I have each of the categories listed. I have the sizes, so you can easily see the sizes. And then if you actually care about the number, I have the number for you there too. This is how I like to make figures, is to remove as much clutter as possible. Some people may think this is going too far. We as reasonable people can debate these things. Your preferences will go into how you construct your figures. If you really despise removing horizontal axis like this, I'm sorry, you're in for a long semester. I do this maybe more than I should. But in this case especially, I think the horizontal axis actually doesn't add that much. We don't need it for really anything. The sizes are represented as they are. Okay, any questions here? So I think the best visualization of this categorical data set is this one. We have the numbers represented on the bars. We have, or we're pretty close. There's one more thing I want to show you. We have colors for each one of the categories, which gives us some visual separation between them. And I've removed as much clutter as possible, including the pesky pie chart. Let's see. It was either Ruby or Luke recommended doing one extra thing. Actually, I think this was Ruby, was ordering them. So states have no inherent order. Pennsylvania is definitely at the top, but everyone else is equally valued. How many of you are not from Pennsylvania? Okay. I'm sorry. I love your state too. But one thing we might do is just order by count. So there's no inherent order with nominal categorical variables like this. But we may want to just order by size. So the last thing we could do is just order these nominal categorical variables by size. And I think this is like the end game of good categorical, nominal categorical variable visualizations. Looks kind of like this. Any quibbles, questions, concerns of quackery? Okay. You think you want to make some nice visuals? Well, here's one last thing, I guess. The one case where it's potentially okay to use a pie chart is with binary categorical variables. So one question we could ask is, how does California compare to the whole? So what's the percentage of coffee shops that are in California? So if we're thinking about percentages, like Chase and Matt brought up earlier, we may not want to use a bar chart like this. So instead, what we could do is just have two categories, right? Instead of listing all the states, we could have California versus everyone else. This is a binary categorical variable. It could look like this. So we have two categories now. You're either a coffee shop that's in California, or you're a coffee shop that's not in California. The bar chart looks fine. We have two categories. And the pie chart also looks fine. How many of you, for this question, would prefer the pie chart? And how many would prefer the bar? Okay. So this is potentially one case where I think a pie chart could work. Best practice is still to use a bar chart, but if you use a pie chart here, that's sort of fine. I will tell you, using pie charts in like good academic research is generally frowned upon. Like, I would recommend you not do it. But here, I would say these communicate equally well the two sizes. And then the last thing is percentages. I would say potentially here, the pie chart is actually a slightly better tool, although I would still default away from them, partly for like cultural reasons. We as like an academic culture generally just stay away from them. But in terms of like the principles we're developing in this class, I would say a pie chart may be actually better in this case. Okay, so the main takeaways here, binary categorical variables, you could use a pie chart or a bar graph. For nominal categorical variables, like we've talked about in this little example, use a bar chart, bar graph, and then order the bars by size. And then if you can add the number on top, that's even better. And then with ordinal categorical variables, we haven't really walked through a big example of ordinal categorical variables, but we're going to do it in exactly the same way. We have a bar graph, and we just order the bars based on their inherent order and not based on their size. Okay, and then general best practices for visualizations. You want to remove clutter, so take out as much as you can to communicate your main idea, and keep it as simple as possible. And then put the visual information, put the information near the visual component. Okay, so we're going to do this together. So you all have your computers. What we're going to do is navigate